Okay, at least 40% of that's going to be algebra. In other words, simplifying, factorizing, things like that. Okay, so let's quickly look at the last thing. Not really the last thing, but the third most important thing is solving equations. There's three aims that you will do in order to solve an equation. One is you want to get a single trig ratio equal to a constant. That is the main idea of solving trigonometric equations. Get a single trig ratio equal to a constant. For example, cos of theta equal to 0,357, or sine of 2 alpha equal to a half, or tan 90, no, let's make it tan of x plus 60 degrees is equal to 7, whatever. So in other words, you have a single trig ratio like sine, cos, tan equal to a constant. You see, that's a number on the other side. Once you have that, you go and you get the reference angle, and then from the reference angle you get the general solution, and after you get the general solution, if they ask it, you find the specific solution. In other words, you substitute. Okay, we'll look at an example just now. That's the most basic, the most common thing that you're going to have to do is try and get a single trig ratio, and the whole effort, where most of your marks are going to come from, is going from the expression that they give you all the way to that single trig ratio equal to a constant. The second thing that you maybe it's impossible to do this. What you might try and do is get a sine something equal to a cos of something else. Okay, if you can't get a single trig ratio, get everything into sine and cos, and try and get a sine with nothing in the front. Here must be nothing. This is a symbol for nothing. Nothing in the front except a 1, okay, equal to a sine equal to cos. If that's the case, you will change the cos into a sine. Okay, you change the cos into a sine so you'll have this sine will just keep the same, but this cos you'll change into a sine, keeping nothing in front, by just adding a 90 degrees inside. Okay, so when you add a 90 degrees into a cos, it changes it to a sine. And it's exactly that, it's co-ratios. You're using a co-ratio. Now, when you've done that, now you've got a sine equal to a sine. But inside, they've got different angles. So you'll choose one of them as your reference angle. Let's choose this one as my reference angle. Doesn't matter which one you use. And then your general solution, you'll use the one that you didn't use for your reference angle, will come on the left hand side. So this one will equal your reference angle plus 90 degrees plus 360 times k. So this was my reference angle, and because I'm working with sine, I'll have another solution. This will be my first solution. My second solution will be the same, but this time where else is sine positive? In the second quadrant. So I'll take this angle is equal to my reference to 180 minus my reference angle, which will be simplified to that. Okay, don't worry, I'll try and find an example just now, and we'll look at an example. Okay, I'm just showing you the general ideas, and then the last thing is, if you find it impossible, this is not necessarily the last thing you'll try. Hopefully you'll recognize what to do. Okay, but the moment you have in your expression a sine squared or a cos squared or a sine cos, then probably what you're going to have to do is factorize. Probably. So for example, you'll get something like sine squared theta minus 2 sine theta cos theta plus cos squared theta is equal to 0,5. No, it's equal to 0. Now in this case, what you should be able to recognize is that this can be factorized into sine theta minus cos theta squared. If I multiply this out, I get that expression is equal to 0. And so this is almost like doing a quadratic equation where I've got now two brackets. Okay? In this case, the two brackets are the same. So I'll have sine theta minus cos theta. So I can just take a square root on both sides. Is equal to 0. So sine theta is equal to cos theta. Now when these angles are the same on the inside, I don't do this long method I just did. I just divide both sides with the cos. Because when I do that, I get tan theta is equal to 1. That's the aim. A single trig ratio equal to a constant. And now I get my reference angle, in this case is 45 degrees. Tan theta is equal to 45 degrees. Sorry, tan of theta equal to 1 is 45 degrees reference angle. Yeah? And then theta in this case is therefore 45 degrees, and for tan, remember the general term for tan is only 180 degrees times k. And that's the answer for this one. Okay, so understand then that there's going to be, and there might be more, but that's the only ones I can really think of that they might ask. One is you will have to use some creative way to get a single trig ratio equal to a constant, or if you find that impossible, then usually it will mean that you might have to factorize. You'll know you'll have to factorize if you see a sine squared, a cos squared, or a sine cos factor these factors in your expression. Then you likely have to factorize, and the idea of factorizing is still so you can get a single trig ratio equal to a constant. That's still the main idea. However, if you can't do that, then at least you try and put everything into sine and cos and get a sine equal to a cos. If this will usually be the case if inside the sine and inside the cos we have different angles. Okay. Or if I have two ratios that's the same with different angles inside as well, this will also then apply. If I have a tan with some angle and a tan with a different angle inside, then I'll also use this method where I make one of them the reference angle. Let's look at the example in here. Okay, this was what we had in the exam. Determine the value of x if cos x minus 60 degrees is equal to 3 cos x. So the method I just described to you is when we have two ratios, and inside the ratios we have different angles. Okay. The problem why we can't do that here is that the main condition for that to use is that there be no coefficient in front. And here we have a 3. So if I say nothing in front, I should have said a 1 in front, okay? And not unless the two coefficients are the same, I can't use that method. So I'll have to use something else here. That method is not going to work. There's no way of getting rid of that 3. I can't divide it on both sides because then I have a third in front on this side. Okay, so it's not going to work. I can't make this, oh, I wish I understand why people do that, and make that cos 3x. Okay, alright, can definitely not, okay, but anyway, so what we will do is we'll need to then either recognize, well, this is going to require something else. This is going to require that I actually expand this using my reference, my compound angles. So it's going to look like I'm making it more complicated, but you'll see now how it's going to help. What will cos x minus 60 change to? Yeah. Cos is? So sine is same sign, different ratio. Cos is?
Different ratios.
No, different sign, same ratio. So different sign, same ratio. So ratio talks about this cos and sine. So this is cos theta, cos of 60. Sine plus sine is same sign, cos is different sign. Sine x sine 60 is equal to 3. Next, what will I do? Which cos? Next is these values. I can simplify that. I know what cos of 60 is. Cos of 60 is a half. Sine of 60 is square root 3 over 2. Okay, so this becomes cos of x times a half plus sine of x times square root 3 over 2 is equal to, now since there's a cos on the left hand side and a cos on the right hand side, it just makes sense that I can subtract them from one another, isn't it? There's 3 coses here, there's half a cos there, so let's just bring the cos to the left hand side, so minus 3 cos x. And all the constants I would take to the other side. It's like a normal equation. Okay, all the x's to the one side, the numbers to the other side. In this case, there's no numbers. So now I've got a fraction here. I've got these 2's here. I don't like working with fractions in there. So I'll just multiply everything with a 2. So now 2 times a half is just cos x. 2 times that, those 2's cancel out, so it's plus the square root of 3 sine x minus 6 cos x is equal to 0. Now I notice, okay, this one and that one I can add together. So I've got 1 cos here, I'm subtracting 6 there, so I'm left with negative 5 cos x equal to 0, and here I've got a square root 3 sine x. I wonder if you guys can take it from here. What could we do now? Remember, my aim is to get a single trig ratio equal to a constant. You can, so let's do that. So we've got 3 sine x is equal to 5 cos x. You can, I would not recommend it, but I don't want to tell you why. Because in this situation, you should immediately know what to do. Remember, if the coefficients in front are not the same, we cannot try and get sine equal to cos. It's impossible. So there must be something else that I can do. Remember, I want a single trig ratio equal to a constant. It doesn't have to be a sine or a cos.
Can't you say 10x is equals to... Wait, let me do it first.
What say? Tan x. What are you doing? Just tell me, how are you getting the tan?
Dividing cos.
Dividing both sides with a cos. Excellent. So on this side it cancels, and on this side I get square root 3 tan x equal to 5. And now? Sorry? You can't find the reference angle. You don't have a single trig ratio equal to a constant. Divide by? No.
Square root of 3.
Divide by the square root of 3. Now you can find the reference angle. Can you use your calculator and find the reference angle for me? So 17,89 degrees is the reference angle. 70. And now my solution, my general solution for tan is lovely. I love the general solution for tan because it's just the reference angle plus 180 degrees times k. So my general solution is that x is equal to whatever is there. That's what comes on the left hand side. In this case it's just an x, so that's great. Reference angle is 70,89 degrees plus 180 degrees times k, where k is an element of integers. Well, that just means if I say k is an element of integers, I'm just going to add 180 once, twice, 3 times. And they did ask me for specific values. They asked determine the values of x, and they gave me an interval. So if they give you an interval, they want specific values. So I'll start with k equal to 0. If k is equal to 0, then I get 70.89 plus 0 times 180. So I don't add 180. That gives me 17.89, and that falls in this interval. It falls. It is less than 180 and more than negative 180. Next is I make k equal to 1. So I'm going to add 180 once. So that gives me 100, 250. Well, I can see I'm adding more than 180, so it's going to be too big anyway. So I can't add anymore. I'm not going to make k 2. That will be adding it twice, and I'm already falling outside. So now I'll go in the opposite direction. I'll start subtracting. So I'm going to subtract 180 once. So it's 70.89 minus 180. Is negative 109,11, is it? And you can see if I'm going to subtract 180 again, it's definitely going to be smaller than negative 180. Okay, so these will be my two solutions. So, yeah? Usually they do take off a mark. Yeah, even though you don't get a mark for it, you lose a mark by not writing it. So I think this was 7 marks, guys. I think the marks was given one for each solution, one for the general solution, one for finding the reference angle, puts us on 4, one for doing this, getting the correct, I think one for simplifying to this, puts us on 4, 1, 2, 3, 4, 5, one for giving the right what is it called, special angle values, and one for expanding the cos using the compound angle. Now if you didn't do that one thing, you couldn't have gotten any of the marks. Okay. Let me try and look at examples of so let's say sine of 3x minus cos of 70 plus x is equal to 0. Let's say we had to solve something like that. I just wanted to show you that other method where we change sine into cos. Then I will have sine of 3x is equal to cos of 70 plus x. So you'll know you'll use that method when your inside angles are not the same. Now if this was just sine of x, then, and if this 70 was maybe a special angle, then I could have maybe applied my double angle formulas and try and get it. But the most important thing to know is that if in front of my ratios I can get the same coefficient, both of them have a 1 there, then it's likely that I'm going to use my co-ratios. So now what I'm going to do with cos is I'm going to change it into a sine by adding a 90 in here. So cos is going to become sine, and when I add a 90, this becomes 160 plus x. And so sine of 3x is equal to that. Now I choose a reference angle. You can choose any one. Okay, let's choose either the 3x or the 160. Let me choose the 3x. And now because I'm working with sine, I'm going to have two solutions. I'm going to have one solution with my reference angle, and I'm going to have another solution with 180 degrees minus my reference angle. So my one solution is, because I use this as my reference angle, that will be my left hand side. So I will have 160 degrees is equal to my reference angle of 160 plus x is equal to 3x plus 360 times k. The only time I put 180 plus k is with tan. Tan is the only one that gets 180, and tan only has one solution. And on this side I will have 180 degrees plus 3x plus 360 times k. Where, and on both sides you must say k is an element of integers. Okay, and on this side, sorry, I forgot my 160 minus x. And now all I do is I solve for x. I get x on its own. So here I'll have to subtract, so I get negative 2x is equal to negative 160 degrees plus 360 degrees times k. And now I just divide everything with a 2. So I get, or negative 2, I get x is equal to negative 160 divided by negative 2 gives me 80 degrees. And then the 360 divided by 2 should be negative 180 times k, because I divided with negative 2. But because k can take any value, positive or negative, we'll just keep it as a positive. It doesn't matter if you make it a negative, it's not wrong. But this is just the amplitude. Not the amplitude, the period. So this is just a period. So whether it's positive or negative, it doesn't matter. Because k is sometimes can be positive 1 or negative 1, it doesn't matter. Okay, on the other hand, on this side, I've got 4x, negative 4x is equal to 118 minus 160 is 20 degrees plus 360 times k. And now if I divide everything with a 4, I get that x is equal to 5 degrees plus negative 5, thank you, plus 90 degrees times k. 360 divided by negative 4 gives me negative 90, but again the same applies, the negative isn't as important.